activation functions. What are the activations? Like we have seen the sigmoid function. There are a lot of activation functions are available. Sigmoid, Relu, softmax, step, tanh, ELU, and leaky ELU. Apart from this, we have something else called parametric Relu, P-Relu. Those kind of activation functions are available. So you know very well the sigmoid function is the mechanism, or it is a S curve. In simple terms, this is a sigmoid function is nothing but the S curve. We have discussed as part of logistic regression. Okay, the function, this is the sigmoid function f of s. Okay, and f of z. This function is a mathematical function having S curve. The function is defined as follows. The threshold function outputs 1 when input is positive and 0 otherwise. Okay, that is what you need to remember it. Any value between 1 and 0, right? So it will convert any value between 1 and 0. The values are bounded between 0 and 1. You remember logistic regression we discussed. And the next one is the Relu rectified linear unit activation function. This is one of the famous and popular, most used activation function in the world right now. It is used in almost all the convolutional neural networks or deep learning. It's a very popular function, okay, when it comes to deep learning. The Relu is one of the popular function for it. It's mostly used in the hidden layer. Relu is used. So they'll ask in the interview. So what is Relu? Relu is an activation function. So it is used in the hidden layers. You need to say that, okay? And so in the case of a Relu, the weighted sum values below 0 will pass as 0 to the output signal. The weighted sum above 0 progress gradually towards 1. See, whenever your function is less than 0, it gives you 0. If it is greater than 0 output, the value remain as it is. See, in the case of sigmoid function, it will convert any value. For example, you are getting 2, 5, 6, or 6.7, and whatever the value you are getting, it will convert, it will transform them into a probability to fall between 0 and 1. In the case of sigmoid function. When it comes to Relu, any value which is 0, it gives us 0. Any value less than 0 and 0, it assigns the value as 0. And whenever it is this function, the Relu function, okay, I'm talking about the Relu function, is less than or equal to 0, it assigns 0. And anything greater than 0, it leaves it as it is. It is not going to convert. For example, you have something like 255. This 255 will remain as it is. It will not convert them to fall anywhere between 0 and 1. But one issue with the Relu function is, all the negative values here, all the negative values, it assigns them, it considers them as a 0 or assigns them as 0. Okay. So in this case, what happens, since it converts or values less than 0, it decreases the ability of the model to fit or train from the data properly. So in that case, what happens is any negative input given to the Relu activation function turns the value into 0 immediately in the graph. So this is going to affect the the model ability to learn from the data. Okay, any value which is less than negative, that should also be taken into account. Since it is assigning 0, in this case, what happens is it is not able to learn the pattern, anything which is less than 0. That is one disadvantage with this one. Negative values become 0, decrease the model able to train the data properly. This is the one you need to remember it. Okay, to solve this, there is something else called leaky Relu. In the case of leaky Relu, it introduces a small negative slope, so it does not have a 0 slope. This helps speed up the training. Range for leaky Relu ranges from minus infinity to plus infinity. The previous case, in the case of Relu, 0 to infinity, but here minus infinity to plus infinity. Which one? The leaky Relu. Look here, it introduces a small negative slope. The next one is the parametric Relu activation function. This is given by f of x equal to max of alpha x comma 0. Alpha is the hyperparameter. So in this case, what happens is parametric P-ReLU, it gives the neurons the ability to choose the best slope in the negative direction. But here, it even in the case of leaky ReLU, it addresses the issue with the ReLU, but still there are some issue here, right? It does not, though it does not have zero slope, the small negative slope will be introduced. But even with the P-ReLU, what we can do is you can choose the best. We'll choose what slope is best in the negative region. Okay, and instead of introducing a negative slope, right? Small negative slope. What you do is you choose this best slope, negative slope on your own, right? So that is where the P-ReLU, that is when it became popular. So they can become a ReLU or a leak ReLU with certain values of alpha. So again, you have some alpha is the hyperparameter. Okay, it's kind of a learning rate. Okay, you can specify some value here. And in that case, based on the alpha value, it may become a ReLU or a leaky ReLU. Okay, so you need to choose the best value, optimal value for the alpha. The next one is tan H function. In this case, it defines the output of that node given input or set of inputs. This is for nonlinear activation function, and it contains the values -1 to +1. So this is little different. So in the case of sigmoid 0 to 1 and Relu 0 to infinity, and leaky Relu -infinity to +infinity. In P Relu, it takes care of coming up with the optimal slope in the negative direction. Tan H takes the value anywhere between -1 to +1. The something hyperbolic tangent function, very much like sigmoid function. The output values for weighted sums below 0 gives -1 in this case. Whereas in the case sigmoid function, any value below 0, it gives 0. Tan H function also not much used, but if you know this activation function also, it is helpful. Now the difference between parameter and hyperparameter in neural network. They'll ask you this question. So what is parameter in neural network? The weights and bias. These two are, and apart from weights, you have something called bias. These two are parameter because the model estimates the value, optimal value for the weights and bias. And the activation function is also activation function hyperparameter. We can use whatever the activation. For example, in the case of hidden layer, still most of them they use the ReLU only. Why ReLU? The sigmoid function. When do I use sigmoid function? 0 and 1. In the case of classification, binary classification, this is good. But even in the case of binary classification, there are some cases they use in the hidden layer, they use ReLU. The reason is supposing you are dealing with an image. You want to do some image classification. In the case of image classification, how the system recognize the images? It recognizes the images by pixels. For example, you have 6 by 6 image. Okay, and here you have the pixels, right? 1, 2, 3, 4, 5, and 6. 6 by 6 pixel is there, and it will be like 6 by 6, it will be there. So in that case, if it converts the value between 0 and 1, what will happen is any value, right? You cannot identify the objects that are part of this image. Hence, what it does is 0 to infinity. So now with the leaky reload or -infinity to +infinity, the reason is each value here, 1, 255, and 3, each value in the pixel has some meaning in it. Supposing you have 3 is, I don't exactly remember it, 3 is kind of white color, 255 is something like, the gray color, something like that. Okay, so in the image, you should be knowing the color, everything. That is the reason why the upper value is going to be whatever the value returned in the previously, that one will be leave it as it is. It is not going to convert or it will not going to transform this value to fall anywhere between 0 and 1, right? So because we are using Relu, Sigmoid function only convert the values to bound between 0 and 1, whereas Relu is not like that, right? So 0 to infinity, any whatever value. With this output of your hidden layer, your subsequent layers can pick up this, and it can find out. Let's in the real time scenario, we will be having more than one hidden layers. Multiple hidden layers will be there. Each hidden layer will gradually learn, new patterns. For example, the first hidden layer will identify the colors and other thing. Second hidden layer will identify the shapes. With the help of the shapes, it can, it can make out whether it is eyes or nose or lips, something like that. With that, it can learn. The next hidden layer will learn. Okay, this is the face, the human face. Okay, it's something like that. Okay, so in order to learn that, you should know the pixel value. Each pixel, see, each pixel has its own value. Okay, here each cell has its own value. Science, in the case of Relu, the upper value is not going to get translated. Okay. Okay, so now you understood what are the types of activation functions are available. And the next one is